Welcome back to this series where I teach you all how to do archival data research here in Matlab. So in this video, I'm going to be teaching you all how to cumulate stock returns or compute the cumulative stock returns. I'm going to show you how to take the monthly stock returns from a data set and figure out the quarterly stock returns from those monthly stock returns for a set of firm years. So we're going to be using panel data. And I'm also going to show you how to take that same panel data set and convert those monthly stock returns to annual stock returns. And then in the next video, I'm going to show you how to do it for a portfolio of companies, not individual firm specific. So let's get started here. First, I want to show you where the data comes from. So I already have the data downloaded, and we'll go ahead and take a look at that. So the data set here is the CRSP monthly file from 2014, January 2014 through December of 2023. I just picked the last 10 calendar years to coincide with this data set where we were computing the financial ratios. But this data set here comes from CRSP, which is a separate data set that's available for purchase subscription within Wharton Research Data Services, or WORDS for short, which I introduced you all to WORDS last time. And if you're an accounting doctoral student or finance PhD student, you probably already know what WORDS is. But just in case you didn't see the last video, Wharton Research Data Services is provided by the University of Pennsylvania. They sell subscriptions to each of these data sets here. These are more like databases, and inside of these are the data sets. Like if you subscribe to this database, then there are 47 data sets within that database. So CRSP and CompuStat are the two databases that are probably the most popular. People subscribe to these the most of all the data sets of all the databases they have access to. And so here's CRSP. CRSP stands for the Center for Research and Security Prices, and it is based at the University of Chicago, and they collect the share price and the returns data, or they collect share price data for all securities that are traded on public stock exchanges in the United States. And then they convert those prices they compute the returns. They have a monthly file and a daily file, so they compute monthly and daily returns. And then they sell their data sets to Wharton, and Wharton packages it under their WORDS platform and then turns around and sells it to us. Now, just because you have access to the CRSP database doesn't mean you have access to all 371 data sets. As you can see, all these that are grayed out here, I don't have access to these data sets, but I do have access to the 5 data sets that are in here. These 5. These are the most common: the daily stock file, the monthly stock file, and so forth. And I do have access to CRSP CompuStat merged, which is, we'll talk about that later, and various stock event data sets here like delisting information. So if a stock delists in a given month, CRSP will go back and put the delisting, the last return they had, the delisting return, which is important to know when you're accumulating returns over time, when you're doing back testing and things like that. You want to be using the correct return. So this is the annual update that I have access to. It's updated once per year. I don't have access to the quarterly update or the monthly update. Those are more expensive. A lot of the bigger institutions will pay for their faculty to have access to the more frequently updated data sets. But I have access to the annual update. So the particular data set that I've downloaded here, right here, it comes right in here. It's the monthly stock file. We're going to be using monthly stock returns in this video. And I just chose over the period 2014 through through 2023. Excuse me. If I open this up here, I just, set this. Excuse me. I just set the time period here from January 2014 through December of 2023. I searched the entire database, and the variables that you'll see in our data set have the SIC code, the share code, and then the monthly rate of return, which is just called RET here. And it includes dividends and see the monthly rate of return variable here in CRSP is already adjusted for stock splits, and it's adjusted for dividends. So that's the cool thing about this. So I just chose those three variables, and then I output the data. I submitted it, and then I saved the CSV file in this folder. That's all I did. Let me log out here. So let's open Matlab, and let's bring in the data. First, let's type ourselves some comments of what this particular script file is going to do, so that 3 months from now, when we come back to this script file and we're wanting to know what this code does, we'll have a little shortcut of figuring that out. So in the second video, we'll do the portfolio returns. But in this video, we'll do the firm level returns. And we'll make it look pretty here. All right, first thing we do, as you've seen in my previous videos, is I clear the workspace. Then I clear the command window. Not that it needs to be cleared here. But I always type these commands at the beginning of the script, because then when I run the entire script, if there's already a bunch of stuff has been run before it, it'll always run these first two commands first. It'll first clear the workspace, then clear the command window. Then I bring the data in. I'm going to bring it in as a table, and I'm going to call that table initial data. We're going to use the read table function. Now let's make sure that we have our path pointed to the right folder where the data resides, and it resides right here. It's in this folder here, so make sure that's selected. And then when you type the read table function, it'll automatically pull up the data sets that are in that folder, and we want this one. And then we definitely want to preserve the variable names. Like I've said in the previous video, you don't have to specify these two arguments here. If you don't specify these two arguments, then the variable names will not be preserved when it brings in the data. So I'll show you what that looks like. So if I run this, actually we'll run everything, Control-Alt, F9. So if we look at the data, actually the variable names were preserved even though we did not put that argument. That happened in the last video as well. I'm not sure why. It shouldn't. I don't think it should preserve the variable names if you don't put that, but it did here. Maybe it's because I've opened it before. If you've opened it before, because usually what it would do is it would just, this would be named VAR_1. This would be named VAR_2, VAR_3, and you wouldn't even know what those variables are. I think because I've run this already before and I've opened it in Matlab, that it's where I did have these two arguments, then it's not making me have these two arguments again, and it's still having the variable names there. But in general, I think this is the way you want if you want to see the actual variable names there. All right, so here's the data. The perm no, or the permanent company number. This is the unique identifying number that CRSP gives each security in their data. Here's the date. This is the last trading day of the month, because we're using the monthly data here, not the annual data. If this was annual data, this would be the last trading day of the year. This is the last trading day of this particular month. Looks like January of 2014. Last trading day was January 31st. This is the share code. And so share codes 10 and 11 are the common stocks of companies. So you have to know that. Share codes 10 and 11. If there's a share code other than 10 or 11, then it's not a common stock. It's like an ADR, an American Depository Receipt, or it's some other type of security. And what researchers usually do is they don't even use the data for share codes that aren't 10 or 11 unless there's some specific reason to do so. So usually all the data that all the securities that aren't common stocks. So in other words, all rows of this data set where the share code is not 10 or 11 are removed before the analysis is done. And that's what we're going to do. We only want to analyze the common stock information because those are the stocks, those are the securities that the average investor could invest in. Whereas those other types of securities, it's not guaranteed that a given investor could even buy those particular things. They may only be able to be bought by an institutional investor, someone who has a license, to buy stocks, like a mortgage broker or stockbroker, if you will. This is the SIC code, the 4-digit SIC code, and this is the monthly return, the monthly rate of return. When I say return in these videos, I'm using that synonymously with rate of return, and that's what academics do. That's the jargon, or the verbiage. They toss around that term return all the time. And technically it's not right. They mean rate of return when they say return. But technically the word return means the absolute dollar return. But that's not what's meant when we say return. It's just faster to say returns. But the rate of return. So if you invested $1 at the beginning of this month in this particular security, so the first trading day of this month, if you invested $1 into that security, you held the security until this last trading day of the month and you sold the security, then your dollar would be worth $1.14.76. You would have earned a 14.76% rate of return, or a 0.1476 rate of return. These are rates. Multiply by 100 to convert to percentages, which we're not going to do right now. So that's what these numbers mean. And that includes any dividends that your security got during that month, and it's adjusted for stock splits that may have occurred during the month. All right. So that's the data. So we have monthly data for each firm for each month. And we want to show you how to figure out the quarterly returns from these monthly returns. That's the idea. So for example, for this security, over the first 3 months of 2014, January, which last trading day was the 31st, February, the last trading day was the 28th, and March, the last trading day was the 31st. What was the quarterly return? These are the 3 monthly returns. What was the quarterly return? That's what we're trying to find here for each of these security quarter observations. We want to convert the monthly returns to quarterly returns. So just as a little example here, if those are the 3 monthly returns for a given firm in a given year, those are the first 3 months monthly returns. Let me show you in Excel here. Let's copy that. And let's come in here and paste it. Those are the 3 monthly returns. Then how would we get the quarterly return from those 3 monthly returns? Will we just simply take the average of those 3 monthly returns? Is that the quarterly return? No, that's not the quarterly return. We want a metric that allows for compounding, right? If we got this rate of return in month 1 on the stock, so if we held the stock and we got that rate of return in month 1 and then we didn't sell it, and then we got this rate of return in month 2 on the value that we already had accumulated by the end of month 1. You see what I mean? There's compounding involved. So the way to accumulate returns is you add the number 1 to each of the monthly returns. And then you have those 3 resulting numbers, 1 plus the individual monthly rates of return. Then you take the product of those 3 resulting numbers, the multiplication of those 3 resulting numbers, and then you subtract 1 from that product. So, if a firm earned a 14.75% rate of return in January of a given year, and then the next month they earn a 2.56 rate of return, and then in March, the 3rd month, they earn a 7.95% rate of return, then over the whole quarter, they earned a 27.06% rate of return. So if they invested $1 at the beginning of January of that year, then at the end of March of that year, their dollar would be worth $1.27. It's a 27% quarterly rate of return. You take each monthly return, you add 1 to it, you take the product of those numbers, and you subtract 1, and that's the monthly rate of return. I'm sorry, that's the quarterly rate of return. It works no matter how you do it. So what if these were the quarterly rates of return for a given year? Let's say the last quarter was, I don't know, so those were the quarterly rates. What if these were the quarterly rates of return? This is quarter 1, quarter 2, quarter 3, quarter 4. Then what's the annual rate of return? Well, you do the same thing. You add 1 to each of the numbers. You add 1 to each of the quarterly rates of return. You take the product of those resulting 4 numbers. And you subtract 1 from that product. That would be the annual rate of return. If you have the 5 daily rates of return in a given week, what's the weekly rate of return? You do the same thing. You add 1 to each of the 5 daily rates of return, take the product of those 5 resulting numbers, subtract 1 from that product, and that's the weekly return, and so forth and so on. That's how you accumulate returns. I don't have time in this video to prove it mathematically why it works, but it does. I mean, what I can do is I can prove it. I can give a little example which maybe will prove it to you a little bit better. Suppose we have the opening price of a stock at the beginning of, let's say, January. So at the beginning, the market opens, the price for the stock is trading for $23.24. Then at the close of that month, so that's the opening price day 1 of the month, trading day 1. And then what's the closing price on the last trading day of the month? Let's say it closed at, I don't know, $12.56. And let's just suppose that that's the opening price on the first trading day of month 2. So the closing price at the end of a given month is the opening price at the beginning of the next month, which isn't necessarily true because there can be trading after hours. But for the sake of example, let's just assume that's true. So that's the opening price month 2. What's the closing price month 2? Let's say it's $11.23. And then finally the closing price month 3. Let's say we're back up to $26.78. So what is the quarterly rate of return? We would take the price that the stock closed at the end of the quarter. We would subtract the price that the stock opened at the beginning of the quarter. And we would divide by the beginning price. So it's ending price minus beginning price divided by beginning price, right? That's the quarterly rate of return. 15%. Now, what if we computed the monthly rates of return? What's the first month rate of return? It'd be the price at the end of the month minus the price at the beginning of the month divided by the price at the beginning of the month. What's the second month's return? Price at end of second month minus price at beginning of second month divided by price at beginning of second month, and so forth. So we should be able to copy this formula down. So these are the three monthly returns. These are the three monthly rates of return. Month 1, we had a negative 45% rate of return. Month 2, a negative 10% rate of return. And month 3, a positive 138% rate of return, because we went from here to here. All right, so from these three monthly rates of return, I'm saying we can get this quarterly rate of return without knowing the prices. That's the actual quarterly rate of return that we would all agree. It's end of month price, end of quarter price minus beginning of quarter price divided by beginning of quarter price. That's the way you compute it theoretically. But if you have the three monthly rates of return over that quarter, I'm saying that you can also compute it by adding 1 to each of the monthly rates of return and then taking the resulting three numbers, multiplying them together, and subtracting 1 from that product. And I'm saying that also gives you the quarterly rate of return, and you can see it does. So I know this isn't a mathematical proof, but I prove it by example here for you that formula, add 1 to each of the monthly rates of return, take the product of those resulting three numbers and subtract 1 from that product. That formula gives you the quarterly rate of return. You don't have to know the prices. All you have to know are the monthly rates of return. So that's enough of that. All right, let's start doing this. So the first thing I'm going to do is delete any row of the data set which has at least one NaN value in that row. So if there's a NaN value in a row, I'm going to delete the whole row. So initial data, and we're going to nest an isNaN within an any function. So isNaN initial data. I'll explain the code here. Don't worry. So what this does is it deletes all rows which have at least one NaN value. So let's take each piece of this by itself so you can see what's happening. So what does this do? This just is a logical array. Oh, whoops. You have to apply that to just the double portion of initial data, because this initial data is a table. It has the data down here, the double portion, and then it has the column headers. So the way to just pick out the double portion or the numeric portion of it is this way. So we apply isNaN to that. And what is that? That's a logical matrix. It's going to be a logical array. I forgot. I did not copy all of it. Sorry. And so it's a logical array that puts a 1 anywhere where there in the original data there is a NaN value. So there's most of the data wasn't NaN, but if we come down in here, I'm sure there's some. Yeah, I saw a 1 right there, and there's. So these must be places in our original table where a NaN value was. So row 247, 358, column 3, there was a NaN value, and so forth. So this isNaN gives you all the places in here where there's a NaN value. And then what does any do? So any of that, comma 2. So this then, what does that do? What does the any function do? What any does, we can either search it by the rows. In that case, we put a 1, or we can search it via column, by column. And so what this code does right here is it outputs for each row. For each row, it'll output either a 1 or a 0. It'll output a 1 if there is a NaN value in any column in that row. and it'll output a 0 if there is not a NaN value in any column in that row. So most of the rows will be, you know, zeros, but there'll be some of the rows where it output a 1 because there must have been at least one NaN value, one or more NaN values in that row. And then all we have to do is say, put all this inside. So which rows of initial data do we want to, oh, I didn't delete these. Do we want to delete? Which rows of initial data do we want to delete? All those rows where the any function equals 1. Those are the rows we want to delete. All these rows, sorry. All these rows are the rows of initial data that we want to delete. Those rows, all columns. So you can see initial data, it started out being 962,992 rows, and now it's 937,816 rows. So there shouldn't be any NaNs now. And we can verify that's true. If we do is NaN initial data, the double portion of it, that'll be a logical matrix, which will be 937,816 by 5 logical, which will have a 1 anywhere there's a NaN in this, but there shouldn't be any 1s in that logical. It should be all zeros. And so if we sum it, and that will sum each column of the logical, so that'll be a 1 by 5 row vector. And then if we sum that 1 by 5 row vector, the sum of each column should be 0, and the sum of those 5 numbers should also be 0. So if this sum is not 0, then there's a NaN, but it's 0 because we deleted all the NaNs up here. All right. Now what I want to do is delete any row where the share code variable is not equal to 10 or not equal to 11. So any row where the share code variable is not equal to 10 and it's not equal to 11, I should say and, to be very precise in my words, because and or are two different things. So initial data, which rows? Whatever rows they are, I want all columns to be deleted. The question is which rows? So we're just going to write a little logical thing here. So any row where any row that's not equal to 10, so not equals, you do that little, if you want equals to 10, you just 2 equal signs. If you want not equals, it's this. So I want to find all those places in column 3, which is the share code column. Column 3. I want to find all those places. So this would be all the rows in the third column that are not equal to 10. But I want all the rows in the third column that are not equal to 10 and not equal to 11. Because if it's not equal to 10, but it's still equal to 11, then I don't want to delete that row. It's got to both be not equal to 10 and not equal to 11. So this right here will be all those rows. This right here will be a logical column vector. And I can show you what it looks like down here. It's a logical column vector that has the same number of rows as this, just one column. There'll be a 0. There'll be a 0 in a given position if that particular row answered false to this, and there'll be a 1 if that particular row answered true to this, logically. So when would a row answer true to this? If in that row there wasn't a 10 or an 11 in the share code column, then this would be true. But if the row has either a 10 or 11, then this would be false, and then there would be a 0 here. So we just put, it's these rows of initial data. So initial data will only pick out the rows where in the answer right here in the logical that are 1. It'll only be those rows, all columns that are deleted. Share code 10 and 11 are common stocks. So let's do that, and you're going to see our initial data matrix, which currently has 937,816 rows. Oh, when we deleted all those securities that aren't common stocks, we're left with 456,375 rows. So now we're assured that every row here has either 10 or 11 in the share code column, which means we're only dealing with security monthly security months that are common stocks. Now what I want to do is I want to take this date variable and I want to pull out the year portion of it and make that its own separate variable, and pull out the month portion of it and make that another separate variable. So to do that, I want to first convert the date variable to a string data type. See, currently it's a numeric data type, but I want to convert it to a string data type. And the reason I want to do that is because I want to use a string function to pull out certain pieces of this. Otherwise, there aren't any numeric functions to pull out certain pieces of this. I mean, there's a way we could do it. Like if we divide this by, what would we have to divide this by? 10,000, and then take the floor, the next lowest integer of that number, and that should pull out the first 4 digits would be the year. But then how do you get out digits 5 and 6? You're going to have to do some, I mean, it can be done mathematically, but it's just easier to convert it to a string and then just use the string function to pull out the first 4 digits for the year and then pull out digits 5 and 6 for the month. So we're going to let string equal, and we're going to convert initial data, all rows, column 2, the double portion. We're going to convert that to a string using the num to str function. So num to str will convert a numeric array to a string array. To a character array, basically. And you'll see what that looks like here. Now you see string is now a char, a car array, or a character array. It's a string array. If I click on this, I won't be able to see everything because of this. It can only display up to 524,288. But I can show you what it looks like. So string, column, row 1, all columns, looks like this. So it's that first date, right here. But string actually, this isn't just one row, one column. This is one row and 8 columns. Column 1 is the character 2. Column 2 is the character 0, and so forth. You see there's 8 digits here. Now I can use the, now what I can do is I can pull out, like I'll show you here, I can pull out the first, so row 1, the first, for example, row 1, the first 4 characters, and that will be the 2014. Or I can pull out the row 1, characters 5 through 6, or columns 5 through 6, and that'll pull out the 01 portion, right, the month. You see? Because it's a string. So that's the string function. So I am naming this string, but that's okay, you can do that. But the string function pulls out the portions of a string. All right. So I'm going to do a lot of stuff in this next line of code. It's going to do a lot of stuff. I'm going to set my new table, initial data. I'm going to add variables to it. So my new initial data is going to be my old initial data with some variables added to it. I'm going to add a variable between these two for the year, and then a variable between the year and this for the month. There's, in other words, 2 variables in here, year and month. So for the year, we need to take string, all rows, columns 1 through 4. But then that's a string. That we can't put that back into initial data. I don't want that. I want a numeric array put back into initial data. So we'll use the str to num function. That undoes what we did earlier. In other words, if I go here, string all rows columns 1 through 4, what does that output? That outputs, well, they're not going to let me see it, but that just outputs, like what if I just did rows 1 through 10? See, that outputs the year, all the years in that date column. So we want all the years in that date column right here. But then that's a string, that's a character array, and I want it to be a numeric array, so convert that back to a number by using the string to num function. All right, and in the third column, I want string to num of string all rows columns 5 through 6. And then those are the two variables that I want to add to this. So to this initial data matrix, I want to add these two variables, this right here and this right here. And where do I want these variables to be added? I want them to be added after the date field, after the date field. And what do I want these new variables' names to be? I want these new variables' names respectively to be year and month. So you have to put this will correspond, this will be the variable's name that you put here, and this variable will be given this name. So how many variables you're adding to your table, you have to have that many new variable names, and that's it. So this adds year and month variable to table. And we look here, we see we have our year and our month. Now we no longer need this date variable. We don't care the actual the day. We don't care about the day. We just year and month. We're computing quarterly returns, so all we need is what year and what month the return was. All right, so we can remove, and we don't need the share code variable anymore either, because we already know these securities all have share codes of 10 or 11. So we're going to use the remove vars function. So we're going to remove these particular variables, date and share code right here. Remember, variables in Matlab are case sensitive. So lowercase shrcd is not the same variable as uppercase shrcd. You got to be careful. So this removes shrcd and date. From the table. So let's run this line of code. No longer do you see date or the share code variable. So now our table has 5 variables: perm number, year, month, SIC code, 4-digit, and then the monthly return. So now what I want to do is I want to go ahead and convert. I want to get over to not dealing with tabular array, but dealing with our with a numeric array. So this is a step that I always do. You guys have seen me do in previous videos. I want to convert to a double array for faster computation. It's faster in Matlab to work with double arrays than table arrays. Now doing that, when I do that, now I lose the column headers, of course. I don't know what columns they are, but I can remember this is the perm number. When you don't have too many columns, you can remember. You can keep track in your mind. That's obviously the month. That's the year. That's the SIC code. That's the return. So, all right. And then what I want to do, you can already see that A is sorted first by firm in ascending order. You can kind of see that. Although we can't prove it, but it looks like it's sorted by firm. Then it's sorted by year. Like we go to the next firm, the earliest year is first, and then the later year is after that, you see. So it's sorted by firm, it's sorted by year, it's sorted by month already. But we want to make sure that that's right. So as a general rule, we want to go ahead and sort the rows of A by firm, year, and month, it looks like. Column 1, column 2, column 3. Just to make sure. Although it's already sorted by that. So this line of code won't actually do anything because it's already sorted by that. But we want to make sure we do that. Otherwise, what we're going to do next, theoretically, won't work. So that didn't accomplish anything because it's already sorted that way, but we always have to have that line of code. All right. Now what I want to do is I'm going to make a placeholder column. I'm going to create a column between columns 3 and 4 for the quarter. That's where we're going to put the quarter variable, because I'm going to add a quarter variable to this matrix. So let A equal the first 3 columns of A. And then for column 4, I'm going to make it a placeholder column. I'm just going to put a bunch of nans there right now. So nan, how many rows of nans do I want? Well, I want how many ever rows of A. First column. I'm sorry, how many ever rows of A. Size of A, comma 1 means the number of the rows of A. The size of A in the rows direction. And then, so that's how many rows of nans I want. How many columns of nan? Just 1, because we want a column vector of nans. That'll be in column 4. And then in the rest of the columns, I just want to be whatever's currently in columns 4 through the end of A. I'm just creating this placeholder column where I'm going to put the quarter variable next. So I just put a column of nans in there. And then we're going to create our quarter variable. So we're going to use the isMember function. So let me show you. If we take A, all rows column 3, and we're going to use the isMember function. So looking in A, all rows column 3, can we find, where do we find, so this will be a logical vector, which will have as many rows as column 3 of A has. And on each row of this logical vector will be a 1 if 1, 2, or 3 is in that corresponding row of column 3 of A, and a 0 otherwise. So we're looking to see, is anything in here a member of this column? And if it is, what rows are those does that happen on? So this right here is just the same thing as typing 1 semicolon 2 semicolon 3, right? Which would just be a column vector with 3 rows, 1, 2, 3. Or you can just type 1 through 3, type 1 and a colon through 3. That means go 1 all the way up to 3, incrementing by 1. So 1, 2, 3, which is a row vector, and then taking the transpose of it, which is a column vector. So can we find this little 1, 2, 3 inside here, or where do we find that? What rows do we find it on? In other words, is this a member of this? And if so, what rows? If not, then just it'll output 0 in the logical vector. So if we look at this here, we see a 1 there, a 1 there, and a 1 there, because in A, 1, 2, 3 is found on those rows. Then we see it again, 13 through 15. 1, 2, 3 is found on rows 13 through 15. right? So if we look here, those should be 1. That's what the is member is doing. It's a logical vector. And so now all we have to do is put this logical, so it's these rows. So A, these rows, column 4, which is our placeholder column that we're using for column 4. So what rows of column 4 do we want to set equal to 1? That's our quarter variable. What rows of column 4 do we want to set equal to 1? Quarter 1. Well, it's those rows of column 3 that are 1, 2, or 3, right? Which rows are those? Well, it's these rows. It's these are the rows in column 3 where there's a 1, 2, or 3. So it's those rows of column 4 of A that we want to set equal to 1. So that'll define quarter 1, and then we can just copy and paste. We have to change this though. It's 4 through 6. So put a 2 in column 4. If you see a 4, 5, or 6 in column 3, put a 3 in column 4. If you see a 7, 8, or 9 in column 3 for the month, July through September. And then finally put a quarter 4 if you see a 10, 11, or 12 in column 3. So let's run this, and our quarter variable should be correct. January, February, and March, that's all quarter 1. April, May, and June, that's all quarter 2. July, August, September, quarter 3. October, November, December, quarter 4. And if for a particular firm year, it skips a month, like we have data on, suppose we had data on this firm year, month, but then we did not have data for this. What if this was missing and it was just 3 and then 5? Well, then this should be given a 1, and then the 5 should be given a 2. Then our code works. We could go and look and make sure, but it works. All right, now what I want to do is I want to create a variable between these two columns. That's going to be the 2-digit SIC code. So let A equal A, all rows, columns 1 through 5. And then in column 6, I want to take column 5, divide it by 100, column 5, divide it by 100, and take the floor of that. So we've done this before in a previous video, I believe, to get the 2-digit SIC code. The floor function it rounds down to the next integer. Rounds down, not up. So like right here, that divided by 100 is 49.25. Take the floor of 49.25 and you get 49. So you can see that works no matter what. This divided by 100 is 40.11, and take the floor of that is 40. This divided by 100 is 73.75. Take the floor of that is 73. So forth. So that'll get the 2-digit SIC code in column 6. And then in column 7 through the end of the new A, I just want column 6 there, I suppose. Or no, yeah, column 6 there. So I'm redefining A. The new A is going to be the first 5 columns of the old A. In column 6 of the new A, we'll take column 5 of the old A and get the first 2 digits. And then in column 7 of the new A, we'll put column 6 of the old A. That's how I'm doing things. I know I'm going quickly, but it's for time's sake. And you can always pause the video and slow down and type things on your screen and make sure you're understanding how things are working, the syntax and all. All right, that's all the preliminary stuff. Now we can actually compute the quarterly return. We have the data in a format that we can compute the quarterly return. And for some reason my computer looks like it's frozen. All right. It's unfrozen now. We're ready to go. All right. So let's type ourselves some notes, and we're going to compute quarterly returns and annual returns, rates of return, but I'm just going to say returns for each, I'm going to capitalize firm, over the sample time period. That's what we're doing next. And then in the next video, I'll leave where I end this code. I'll continue this code, and I'll compute quarterly and annual returns for each portfolio over the sample time period, and I'll show what I mean by a portfolio. We'll pick certain portfolios, and I'll show you how to compute quarterly and annual returns for the portfolio. All right, so now we really have to think. Now the meat of our code is going to start. We got all kinds of firm monthly observations, firm year month observations here in this data set. I mean, this is a nice firm. It has, in 2014, it has all 12 months of data. But not every firm year will have all 12 months of data. There may be some firm years that only have 1 month of data, and so forth. So whatever we write next in our code has to accommodate all those possible combinations. We can't write something that'll only compute the quarterly return correctly for firms that have all 12 months of data in a given year, but won't compute the quarterly return correctly for firms that don't. It has to work no matter what. I mean, if you go down here and look, there's lots of firms that don't have all 12 months of returns for a given year. I could pull out numerous examples. It may be hard to do it just by going like this, because so many of the firms do have 12 months of returns for each year. The majority of firms are fine, but there's plenty of firms that don't. So, and I leave that to you to verify that. So what we want to do is, what I want to do is go row by row down through A. Actually, I want to go 3 rows at a time, starting on row 1. And we'll move to row, then we'll increment and go 3 more rows at a time, and then 3 more rows at a time. This is what I'm visualizing. And what I want to check is I want to say, if the firm is the same in these 3 rows, the year is the same, and if the quarter is the same in those 3 rows, then the quarterly return, I can use these 3 monthly return numbers. I can add 1 to these 3 numbers, take the product of the result, and subtract 1, like we showed you in the example. But only if those 3 conditions are satisfied. The firm has to be the same, the year has to be the same, and the quarter has to be the same. And so probably the fastest way to do this is we can use the diff function. So if we apply diff to let's just say rows 1 through 3, column 1, what do you get? What it does is it takes these 3 rows right here, and it computes the difference, the element-wise difference. So this minus this, which is 0. And then it computes this minus this, which is 0. So if you have 3 rows, diff is going to have two rows. It'll be the difference between second and first, and the difference between third and second. In that order. It's always this minus this, and this minus this. Not this minus this and this minus this. Diff works this way. It's this minus this, 2 minus 1, 3 minus 2, 4 minus 3, and so forth. So the diff of these 3 will be this, as you see here. So then if we take the sum of that, that should be 0 if these 3 are the same. So that gives us a hint. And we're gonna have a for loop here. So for I equals 1, increment by 1, go all the way up to the side, to however big A is in the rows direction, but then we're going to subtract 2 from that because we are going to increment. We're going to go 3 rows at a time. Right? Boom, boom. And so we have to stop. We have to stop right here, the size of A in the rows direction, which is 4, 5, 6, 3, 7, 5. But minus 2, though, we have to stop here because our last is going to be this. We can't stop here because then when we increment up, it's going to be an error. It's going to, when we go to this row, it's going to say that row doesn't exist of that. You see, so that's why we say minus 2 here. And then if the sum of diff A, rows j through j, not j, I through I plus 2, column 1, if that sum equals 0, and that's what we were just doing just a minute ago, we took the diff of this, took the sum of that diff, and that should be 0 if these three numbers are the same, and it will be not 0 if these three numbers aren't the same. So that has to hold. Another condition that has to hold is in the second column of A, these three numbers have to be the same. So all we have to do is just copy and paste this and just change the column. And these three numbers have to be the same. It has to be the same quarter, which is in column 4. So if those three conditions are satisfied, so we need firm to have 3 consecutive months of data and the year to not change over those 3 consecutive months. Per quarter. And this condition ensures that that happens. If this condition holds, then we know we have a firm in a given year with 3 consecutive months of data. And if that condition doesn't hold, then we don't have that. And these 3 conditions cannot, there's many different ways they cannot hold. See, this is actually the really important part. If these conditions are wrong, then our code's going to be wrong. If these aren't the right conditions, then our code will be wrong later on. We need the firm to have 3 consecutive months of data, but not only that, the year can't change over those 3 consecutive months, right? If this is 1, 2, 3, but this is 2014, 2015, 2015, well then that's not going to work, right? That's not quarter 1. You don't have all the data for quarter 1, 2014. Even if the firm's the same, you know what I mean? And I'm sure there's instances down in the data where that happens. So the firm's got to be the same for the 3 months. The year's got to be the same for the 3 months. And the quarter variable has to be the same for the 3 months. Then we have 3 consecutive months of data. And the firm year does not change over those 3 consecutive months per quarter. And then if that's true, then we're going to define the quarterly return, row I, all columns, to be A, row I, columns 1, 2, 4 through 5, or 4 through end minus 1. 1, 2, 4 through n minus 1. So the quarterly return in that given row will be this, whatever A is on that row in columns 1, 2, and 4, and 5. 1, 2, 4, and 5. And so then in the 5th column of quarterly return, that's four columns. And then in the 5th column of quarterly return, we want the actual quarterly return, which is going to be the product. Now in Matlab, you take the product using the prod function. The product of A, rows I through I plus 2, column 6, or column end. We want to add 1. So we're taking the product of that, right? This is a 3 by 1 vector, 3 rows by 1 column vector of returns. When we add 1 to it, it adds 1 to each of those numbers. And then we take the product of that resulting set of numbers, and then we subtract 1 from that product. I think that should work. So compute quarterly return by cumulating the monthly returns correctly using the correct formula, which that's the correct formula. So if these conditions are satisfied, then on row I of quarterly return, it'll be that. But what if the conditions are not satisfied? So else, then just let row I of quarterly return equal nan. So nan with one row and how many columns, whatever the size of a comma 2 minus 1. So 5 then, right? The size of A in the column's direction is 6, but then we subtract 1, so 5. So we want a row of nans, one row of nans, 5 columns. Because quarterly return will have 5 columns in it, right? We'll have row 1, row 2 of A, row 4 and 5 of A, and then the 5th column of quarterly return will be the quarterly return. And so there'll be 5 columns. But if this condition is not satisfied up here, just let the ith row of quarterly return equal a row of 5 nans. All right, and then we end the if-then statement, and we end the for loop. And I believe that's it. So let's go ahead, and I'm going to hit CLC here. Let's go ahead and run this. This may take a second. Let's run this. Because we're having to increment through the matrix A, and A has 456,375 rows. And we're incrementing row by row through it, right? Starting on row 1, we're looking at the 3 rows. Then move to row 2, we're looking at rows 2, 3, and 4, the next 3 rows. And moving to row 3, we're looking at the next 3 rows. And we're going down A like that. That's what this code is doing. I think this takes about 106 seconds to run. If you want to know how long a block of code takes to run in Matlab, just put that block of code inside of a tick-tock like this. So if I run this, then this code right here will run, and after it's done running, it'll spit out on the screen how long it took the code to run, like 105 in seconds, like 105 seconds, 106 seconds, how many ever seconds. And that's useful sometimes for pieces of code that take a while to run. And if you already know how long it's going to take, then you can leave your computer, and come back 2 hours later if it takes 2 hours, and then be ready to run the next thing. So it's done. And because I didn't put this within a tick-tock, it didn't show on my screen how long it took. But that's how you do it if you want to know how long it took. So if we look at our quarterly return matrix now, row 1, that should be the quarterly return because these 3 numbers are the same, these 3 numbers are the same, and these 3 numbers are the same. So row 1 of quarterly return should be the product of these numbers plus 1 divided minus 1, which, we can check. Control C here. Let's go copy and paste into Excel, make sure that it's computing things correctly. So 27.06% or 0.27 basically. And what did we get for quarterly return row 1? 0.27. Of course, rows 2 and 3 is going to have nans there. Why? Because our code in row 2, one of these things is not satisfied, right? If we start in row 2, then these 3 are the same, these 3 are the same, but these 3 aren't the same. So row 2 of quarterly return, all nans. And now all we have to do is get rid of all the rows in the quarterly return which have a nan in them, or which are all nan in this case. Well, either way, if they have one or more nans, get rid of it. So what I'm going to do is quarterly return. And I'm going to do this the same way as I did with the same sort of logic as up here. Delete all the rows which have at least one nan. Except I'm going to delete all the rows. I could use the any function down here and it'll work. But what I'm going to do is I'm going to use the all function. And what that does is it deletes any row of this matrix any row that has all nan values in it. So if a row doesn't have all nans in it, it won't delete that row if we use the all function. Now I realize you can use any or all here and it'll work, but I'm going to show you. So quarterly return all is nan quarterly return. The isNan quarterly return is just a logical matrix like I've shown you already, and in the columns direction. So we want to look row by row, and in a given row, is it all nan in that row? If so, then delete all those columns. Deletes any row which is all nan, or which has all nans. All right, and then let's go ahead and run that. So here's our quarterly returns. So we're done computing quarterly returns. It leaves us with 150,200 firm year quarter returns for which we can compute them. And then we could take these quarterly returns and do stuff with them. What we may want to do is we may want to join or merge this data set with CompuStat quarterly data. And we'll show you how to do that in a future video. Say we want quarterly accounting fundamentals and quarterly stock returns. Well, the stock returns are computed using CRSP data like we're doing here. The accounting information is in CompuStat, and then we could merge the two data sets together. Like if we want to know, now this is the perm number, this is a security identifier, but the common stock, the company that this common stock belongs to, 2014 quarter one, what was its net income? If we want that in this data set as well, then we're going to have to merge this with CompuStat data. There's its quarterly return. I think I've lost in this process, I've lost my 2-digit SIC code because I had done this, but then something down here, I don't have the 2-digit SIC code anymore. And I think the reason I don't have it is in this right here. I want my quarterly return to be A1 through, so A no longer has the 2-digit SIC code. So let me redo this. I'm just going to do this part first, to where I know I have the SIC. There's that. And then so A1 through 2, 4, 5, and 6. I guess I don't think I ran this line earlier. So let's just go ahead and then we can run all this. This should all work. The code is right. It's just I didn't run that line right there. So this will take another 105, 106 seconds. I think that's what this part of the code, how long it takes to run. It's a little bit longer because it's doing more. And then all we have left is are the annual returns, which we can compute from the quarterly returns, like I showed you in the example. If these are quarterly returns, well, we need another one. Then how do we get the annual return? We add 1 to each of the 4 quarterly returns. We take the product of those 4 resulting numbers and we subtract 1 from that product, and that will be the annual return. For example, with this little mini example, if these were the quarter 1's return, quarter 2, and quarter 3, quarter 4. So that's what we're going to be doing next. So we're going to be looking at our quarterly return matrix that we've created in this step to do the next step. So things build upon each other in this code. It's like a domino effect. All right, come on, come on. You can fast forward the video a little bit, but it'll be done here in just a second. All right, it's done. Here's our quarterly return. We have our SIC 2-digit code. We need that for later, for not this video, but the next video. All right. So now in our quarterly return data set or matrix, we want to use this to compute our annual returns. And so again, in this matrix, we're going to go down 4 rows at a time, starting at row 1. If these are the same, and if these are the same, and if these 4 rows equal 1, 2, 3, 4, then we can compute the annual return. If that makes sense. Then we can take these 4 numbers and compute the annual return with them. But if one of those conditions is not satisfied, then we can't. So we're doing a for loop. I ranges from 1. I starts at 1, increments by 1, and goes through however big our quarterly return matrix is in the rows direction. Subtract 3 though. Subtract 3, not subtract 2, because we're starting in a given row and we're going 3 rows ahead. So that row through that row plus 3. So 4 rows at a time. That way we have to stop right here on this row because this row plus will be the end of the matrix, you see. Subtract 3. So the size of quarterly return 1 is this number here, 150, 200. Subtract 3 though, because that's where the last row where we're going to do it, where I needs to stop. So if the sum of the diff of quarterly return row I through I plus 3, column 1, if that sum is equal to 0, then following the logic earlier, that means that these 4 numbers are all the same. And we want that same thing to happen in the year column. And it's not enough that the firm's the same and the year's the same. We also want to make sure that these numbers are 1, 2, 3, 4. So and quarterly return row I through I plus 3 column. What column is that? Column 3. Column 3 needs to equal you can either do it this way, 1, next row 2, next row 3, next row 4. That's a column vector, 1, 2, 3, 4. Or you can just go 1 through 4 like this. That's a row vector, and then take the transpose. 1 through 4, incrementing by 1, 1, 2, 3, 4, then take the transpose, which is the same thing. So these 3 conditions have to hold. Why? Because we need the firm to have at least 4 consecutive, not at least, but to have 4, exactly 4 consecutive quarters of data per year. So if that's true, then we're going to let our annual return matrix row I, all columns, I'll just call it annual REIT like that, equal, well, whatever we have in our quarterly return matrix on row I, columns 1, 2, and then 4 through end minus 1, so 4 and 5. So Like if you just want 1 through 2 here, you just do like this. But if you want 1 through 2 and then skip 3 and then 4 through n to minus 1, which is 4 through 5, then you have to put it in here. So those columns of row I of quarterly return. And then after that, we want in the last column, we want the product of quarterly return rows 1 through 4. Plus 1, minus 1, like we did before. So rows I through I plus 3, column end, add 1 to that. Take the product of all that and subtract 1. So this computes the annual return by accumulating the quarterly returns correctly. Trying to be symmetric with what I did up here. All right, so we're still in our if-then statement. So if these 3 conditions hold, then this. But what if those 3 conditions, if one of those things is not satisfied, then else let annual return row I equal just a row of nans, just like we did up here. So it's one row, and then how many columns, whatever the size of quarterly return is in the columns direction, and then minus 1. I need to be consistent here and put this both places. Oh, that's messed up. All right, and then end the if-then statement in the for loop. And then we can run this. Now this will not take as long as earlier because here we're iterating our way through the quarterly return matrix, and the quarterly return matrix only has 150,200 rows, whereas A had 456,000 rows. So it's already done. So here's our annual return. There's nans in certain rows. So then we want to run this line of code again on the annual return matrix, but get rid of all the rows that have nan in them. So just change these 2 pieces of it. Run that. There's our annual return matrix. We have 35,425 firm year observations over this 10-year calendar time period for annual rates of return. And yeah. And now finally what I want to do is create 2 table arrays. I want to convert this to a table with the variable names, and then convert this to a table with the variable names. So quarterly, I'm going to call it return equals array to table. We're creating a table now from our quarterly return numeric double array. And the variable names are going to be, first, it's permno, then year, then in column 3, it was, I believe, quarter in this particular. If we go back here, it's firm, year, quarter, SIC4, SIC2, quarterly return. We're just giving the names of the variables however we want to name them. I'll just say reach because it's quarterly return is the name of the table, so this is the quarterly return. I don't have to say here quarterly return. I mean, I guess I could, but I'm just going to call it read. So put into table and label variables. And then just do the same thing for the annual as well. And we just have to change This one will have one less variable. Right? Annual return has one less. So it's firm, year, SIC4, SIC2, and return. So change this. And change this. All right, let's run these two lines. And we have our quarterly return table with the actual variable names. And we have our annual return table with the actual variable names. All right, in the next video, what I'm going to do is I'm going to continue my lines of code here. I'll go ahead and set up the next video. We're going to, but we won't get into it. We're going to be computing the quarterly returns and annual returns for each two-digit SIC code portfolio now, not firm, it's a portfolio level over the sample time period. That's what we're going to be doing in the next video. I'm going to show you, not just for the SIC 2-digit, also 4-digit. We'll do it both ways. Highlight this, Control J gets everything inside the vertical lines, like I've told you before in a previous video. When you have comments that go over this vertical line here, you just highlight everything. Control J will auto fit them inside there. Unless the comments are like this and they're like on this row, it has to be only comments on that row, then it'll do it. Like here we have some actual code. But anyway, I'm going to save that and we'll start from there in the next video. So I hope you learned something in this video and you enjoyed the video, and I will see you on the next one.